So I've completed the last bit of the section 5 problems and read section 6. So section 5 is all about permutations. And I have already done a boatload of problems. I was up to problem 53 during the last update. And I've already shown these pages in the previous updates. Yeah, so this is really beginning in problem 54 all the way down to the last problems here in section 5. Yeah, permutation with an odd number is an even permutation. The opposite is also true. Got that right. Every element in A sub n for n greater than or equal to 3 can be expressed as a 3-cycle or a product of 3 cycles. I looked at the answer. That's not what I attempted. I got it wrong. Yeah. Then I worked through some transpositions. I actually made a video of me calculating transpositions that'll come out in a little after this update. Then 58, of course, I don't have an answer, but I gave it a good try, which is the center of S sub n is the identity. Then the Verhoeven check digit scheme, checking that it works. I just worked it all out. Sure enough, it does. When you're comparing the sigma values, they're supposed to be different. So yeah, sigma of the number is supposed to be different to the result of multiplying it in the table. You have to keep going back to the table and checking the products. And then the products are always different. Yeah, I'm not saying it correctly, but yes, I got it right. Yeah, I mean, the book doesn't have the full answers, but I know I got them right because I could check every single pair of numbers and they were different. Every element of S of n can be written as a product of elements of the form 1k. Yeah, I got this correct. Yeah, I actually did this on the train. And then this one with card flipping, I used my method that I have used before that I made a video of. Just fill in with blanks as you go from A10, A blank 10, 10 blank Jack, Jack blank 6, 6 blank 3. Write them all out. And this is a brute force method. I'm sure there's a more elegant way of doing it. But I just go through all the cards. The 2, you try to line them all up, and then you end up at a point where it's wrong. The 3, you end up at a point where it should be 10, but it's 5. 4, just doesn't, it dies off. 5 gets to a point where there's a contradiction where it's trying to go somewhere and it isn't. Sure enough, when you hit 9, you just go right through, and then that is the correct answer. So the first shuffle that you don't see is this shuffle right here, and the final shuffle is the one that is given as the answer in the book. For 63, I screwed it up. I said n is greater than or equal to 4, but it really is n is equal to 1, 2, 3, 4. And it's no for n is greater than or equal to 5. Yeah, I just messed that up. 65. Yeah, I just didn't do it right. I wrote out the answer from the book. 67. I think there was a minor error in the answer in the book, but it's in the answer book, but it's so silly that it's, I know I got it right. Then reading section 6, all about isomorphisms. Of course, basically the theme is if you change the numbers on any one of these Cayley tables, every single number by some other number, you still have the same relationship. That's basically what you're getting at. Then codified into two theorems, 6.2 and 6.3. 6.2 is the action on elements. 6.3 is the action on groups. And some of the problems I've already been working on get down to proving some of the parts of theorem 6.3. Going back to D4 in the example, an example of the inner automorphism, where in the case of the inner automorphism, you calculate out these similarity transformations. That's what they really are, back from linear algebra. That's what I would call them. Then the explanation that the automorphism of the integers is an isomorphism with the U groups for the same n. And then in the case of example 16, I decided to work them all out myself just to understand. And sure enough, there is an error in the book, I believe. One of the terms is incorrect. Yeah, so that closes out reading for section 6.3. I mean, section 6.